There's this incredible piece of technology that's quietly changing everything about how AI understands the world. It's called a vector database. And yet, it's the secret sauce behind this whole AI search revolution we're seeing. So today, we're going to break down exactly how it all works. So let's kick things off with a really big question, something that gets right to the heart of it. How can a computer search for an idea instead of just a plain old word? I mean, how does it actually grasp what something means? This is the core problem we're talking about, and trust me, the answer is just fascinating.
Okay, so to really get this, we have to look at a totally new kind of search, one that goes way beyond just matching keywords. And this right here, it lays it all out perfectly. The old way, keyword search, is completely literal. It's like you have to know the exact title of a book to find it in the library. No wiggle room. But the new way, what we call semantic search, it actually understands context. You can just describe what you're looking for, like tech company that makes phones, and it just knows you mean Apple. See, it's searching for the meaning behind your words, not just the words themselves. And that is a huge, huge leap forward.
So what's the secret sauce here? How does this whole semantic search thing actually work? Well, it all comes down to a bit of magic called embeddings. This is the key process for turning all kinds of data into pure, understandable meaning.
Let's break this down. Basically, embeddings are just a way to turn anything, words, pictures, even sounds, into a string of numbers. We call these numbers vectors. But here's the crucial part. These numbers aren't random at all. They're carefully calculated to capture the real meaning and context of the original data. You can almost think of it like a universal language for ideas that a computer can finally, truly understand.
Okay, the absolute best way to wrap your head around this is to imagine a giant, sprawling map. But instead of places, it's a map of meaning. Every single concept, every word, every image has its own specific spot on this map. And this is the perfect example. On our meaning map, the word king is located right next to queen because, their meanings are super related, but both of them are miles and miles away from the word apple because that idea lives in a totally different neighborhood on the map. It's all about how concepts relate to each other. It's all about proximity.
So who draws this incredible map? Well, these super smart AI models, like the ones called transformers, are basically the cartographers. They read and process just insane amounts of data, the entire internet, books, images. And by doing that, they learn all the subtle connections and relationships between ideas to create this incredibly detailed meaning map.
All right, so we've got our map of meaning. Now the big question is, how do we actually use it to search for stuff? Well, this brings us to the next step, searching by similarity. It's really all about finding the closest neighbors on the map.
Once you have this map, the actual searching part is, it's kind of beautiful in its simplicity. Similarity search just finds the closest items to whatever you're looking for. So if you search for king, it doesn't just look for the word king, it finds the point on the map for king and then says, okay, what other points are right here? And boom, you get queen, monarch, royalty.
So how does a computer figure out what's close? Well, it all comes down to some pretty cool math. First, like we said, everything is a point on the map. Then the database calculates the literal distance or the angle between your search terms point and all the other points on the map. And finally, the points with the shortest distance are your best, most similar results. It's basically a GPS for ideas. Okay, I know this might all sound a little abstract, like something out of a sci-fi movie. But here's the thing, you are using this tech every single day. So let's look at where these vector databases are in action, powering the world all around you. This whole process you see here, this is the engine running behind the scenes. From gathering tons of data to training the AI model, this tech is what provides you with those super personalized experiences you get online, all in real time. It's the magic behind so many of those seamless moments you probably take for granted. And I mean, think about it. Where do you see this stuff? You know when an online store gives you those scarily accurate shopping recommendations? That's vector search. When your music app suggests a song you immediately fall in love with, that's it too. That reverse image search, where you upload a picture to find similar ones, you guessed it. It's even being used for really advanced fraud detection. And of course, it's what's making our search engines so much smarter.
So let's bring it all home and talk about the future, because this isn't just some neat little feature. This is the future of how we interact with information. We're heading into a truly semantic world. What we're looking at here is a massive leap forward, a real game changer in how we deal with information. For decades, we had to learn the computer's language of rigid keywords, but now, finally, Computers are learning to understand our language, the language of concepts, context, and ideas. And that is driving just incredible efficiency and innovation everywhere you look.
So if there's one thing to take away from all this, it's that we're shifting from a world of just matching words to a world of understanding meaning. And that leaves us with one last really fascinating question to think about. As everything, our text, our images, our music, even code, becomes searchable by its true meaning, what kind of new questions are we going to think to ask next?